Okay, when you open up the Pandas and Spotify notebook, you'll see, as is typical, that the first cell contains a number of import statements, including import pandas as PD, which means that when we use pandas, we can refer to it by just typing PD rather than the whole word pandas. We also have three visualization module import statements. And those we'll get used to. We'll spend time with figuring out and talking about those. The second one here is what it does is when Pandas has more columns than it can show, it cuts out the middle columns and only shows you the beginning columns and the ending columns. We don't want that. And what this command does is that Pandas will show all of the columns and you scroll back and forth to see them all. And so, that's sometimes helpful depending on the size of the data frame or the width of it. Again, we have a URL that is where is being stored. And we just we do pd.read CSV to read that CSV file into a data frame, which we're calling DF. This encoding Latin 1, sometimes we have some characters that are not part of the standard character set, and we have to give it this encoding command. And that, again, is not something you need to worry about right now. Okay, so the first thing we run is the df.shape. That's not actually the first thing we should run is the first cell. And otherwise we get an error as we got. So we run this, we import, upload our stuff. And when that is done, we will be ready. So now we load the data frame and then we run df shape. And df shape in this case, if I just run df shape, what it gives me is this. It gives me that there are 953 rows, 24 columns. So that means there are 953 different records, and each record has 24 different attributes in this particular data frame. Okay, the next thing we run is df.info, and what that does, and this is important, it gives us a list of all the columns. And so there are 24 columns. They have numbers from 0 to 23. And this tells us how many records we have in each of those columns. You can see, for example, that in Shazam charts, we're missing some records because there are only 903 values, which means that we're missing 50 since there are 953 rows. Only 903 of them have values in Shazam charts column. We also have the data type. We have some object, which are, for the most part, text. So the track name, the artist name, and then we'll have something like this, streams, where we see its object. That's weird to us, so there's probably some reason for that. There's a stray comma in there or something like that. Key and mode, we'll look at, see what those are. So this is the metadata here, and this is something that was just imported. This is not like a Pandas command to run this. We just copied and pasted this into the notebook. And this gives us more detail about what each of these columns does. And so basically what we have the name of the track, of the song, and the artist name. We have the artist count, like if there's more than one artist who worked on this particular song. We have the year, month, and day of when it was released. And then we have all this data about the charts and playlists that it showed up in, how many streams, etc. And then starting with BPM, we have data about the song beats per minute, key, and then these things like how danceable it is, whatever that means, the valence, which is whether it's positive or negative for the musical content, the energy level, acousticness. So when you're describing this, if you just say it gave us the name of the artist and the track, it gave us information about when it was released and about how many playlists and it showed up on, how many streams, and then it gave us a bunch of information about the song, like, beats per minute, key, etc. So you don't have to go into, the kind of detail where you'd have to describe every column. Okay. Next thing we do is we actually take a look at the first in this case, 24 records. We could have put any number in here. If we don't put a number in at all, it defaults to 5. And so I can scroll and I can see, what I have here. One of the things that I notice is that streams is a number, but right here we have this letter A, and that made Pandas turn this whole column into an object column instead of to a numerical column. That kind of thing happens. We will learn how to deal with that. We won't worry about it in this particular case. Okay, the next thing we have is that we just look at the tail. So we look at the last, in this case, 5 records. And so we get just a sense of what the last, and these are more recent up through 2022. By the way, the breakdown of the data columns, of the column data types. So you can just tell me there's 1, 2, 3, 4, 5, 6, 7 objects, and the rest are integers. And that's all that we're asking for in that question. And again, the column that should have been listed as numerical but wasn't is the streams column. And again, we'll deal with that in the future, what one does in that situation. So then we want to know the code that would show just the key and the mode columns. So when we want to show just specific columns, we can just do something like this. We can say, this will show me just the track name. I have the DF, the name of the data frame, followed by the square brackets inside the name of the column in quotes. If I want to show more than one, I have to do something a little different, and this will be a source of confusion for a long time, I can guarantee you that. So instead of putting just a string in quotes, we put a Python list, which means that it's enclosed in another set of square brackets. And inside those square brackets, we have all the columns that we want to show enclosed in quotes. So we have this little list of 2 elements here inside these outer square brackets. And so when we run that, we get an error because we did not do this correctly. So now we look and see the track name and the released year. Okay, so that's how we would look at columns. And then you can just change the name of the column or columns to do something different. Okay, so if we want to show just the key and the mode, then we would change what we did here to key and to mode, and that would give us the key and the mode. Okay, so then this value counts. What this does is when we have an object or a text column, we may have some repeats in there. It may really just be categorizing, and it may be more of a categorical variable. And this is not exactly categorical, but what it does is it tells us that Taylor Swift shows up 34 times in that column. So there are 34 of her songs in here. The Weeknd shows up 22 times, Bad Bunny 19 times, etc. And so this does a count for us of how many there are of each different artist in this. If we did, for example, track name, then we would get something pretty different because, we have a couple songs that show up twice, but most of them are just going to show up one time. Okay. When we add the .head 20, we automatically get the first 20 here instead of just like the first 5 and the last 5, which is what you get when you don't have that add 20. Okay, so we also want to check the most common key, and so to do that, we can just change this to key. When we do that, we can see that C# was the most common key, and that happened 120 times. Okay, what were the most and least common months of release? Well, again, all we have to do is change this to the name of the months of release column, and that was just this released month. And so we'll put that in here, released month. And so now we get that January was the most common, then May, then March, etc. And if we wanted to find out something like the most common, month and day, we could do something like this, where we would have not just one, but we would have two items in here. And that means, again, we need to add the extra square brackets because now we're not just putting a single string in here, we're putting a list inside. And what this tells us, it tells us every different combination of month and day. So January 1st was the most common release date. May 6th was the second most, and May 13th was the next most. So when the month is the same 2 times in a row, it doesn't repeat the month for you. So we also want to know, what is the mean energy level? So when we want to do something like that, there's a couple ways to do it. One is we can use this df.describe. And what that does is it gives us, for every numerical column, it gives me all this information. It gives me the count, how many there were, the mean value, the standard deviation, the minimum, 25th percentile, 50th percentile, or median, 75th percentile, and maximum. So these 5 numbers here are the 5-number summary. And so when we scroll over to the energy level, and we want to be in the mean column, so we want the second value in the energy column, and we get this energy percentage of 64.28. That's the mean energy. We don't know exactly what that means, but we have songs that go up to 97 and down to 9%. And if we wanted to, we could go find what songs those were, and we'll talk about that a little bit. Okay, so question number 9, we had the day of the year that is most common, and we found that was January 1st when we asked to do a value counts of both day and month at the same time. Okay, so then we also we want the code that'll show, among other things, we want to see the first 10 records. So that is just df.head, and we put in the number 10 there. And then it asks us the last 10 artist name and track name. And so what we can do is we do df, and we want 2 columns, so that's going to be a second set of square brackets, and we have artist name. Actually, let me do this, and this is a good tip. You're often referring to column names. It's very easy to forget what those column names are. So if you just type in df columns, it'll give you the column names, and that way you can do copy and pasting from that instead of having to type the names all the time. So I want df, and I want to do the last 10 artist and track name. So again, inside my double square brackets, I have artist name. So I can just copy and paste that in. And I want the track name. Again, just copy and paste that in. And so now when I run that, I get, well, this shows me automatically the first 5 and the last 5. But if I want to see the last 10, I just add tail to 10 to that, and I get the last 10. Okay, now I want to see the danceability values sorted. So what I want to do is I'm going to add code, and I'm going to have df, and I'm going to have the danceability, which is this danceability percent. So we'll copy and paste that. And that just goes inside the square brackets. And when I want to do it, when I want to sort, I would add sort values, open parenthesis, close parenthesis. And that gives me all the values sorted from lowest to highest. But if I want to see everything, I don't want to see just that one column, I would do df.sort values. And inside the parentheses, I would have the name of the column that I want to sort by. And so now I can see them. They're still sorted by danceability, but now I can actually see the names of the songs. So the least danceable song was White Christmas from Bing Crosby in 1942. If I want to see at the end here, I can stick a tail onto the end of that, and I can see that these are the most danceable down here. Okay, so then I want the percentage of songs that are in the minor key, and you don't need to do that completely in code. We know there are 953, and we can say df key and do value counts. And so that'll tell us, I'm sorry, we want not that, we want mode. That'll tell us that there are, out of all 953, there are 453 in the minor. So we could just do 100 times 403 divided by our total of 953 records. So that tells us this is our percentage that are in the in here. And the two questions for you to come up with is just whatever would be of interest to you. You could find the least danceable, the one or the song with the most positive valence, or is there any relationship between danceability and beats per minute, or any of those sorts of things you could do. And those would be questions that you could explore using this data.